states that we are given n number of rows which has 10 columns in itself, like there are 10 cells in each row. Now there can be n, and that n has a limit, right? So the n can be from 1 to 10 to the power n, which means, and the number of reserved seats length, right, that is minimum of 10 into n, or else 10 to the power 4. So it is like maximum it can go till 10 to the power 4 only. That is the maximum it can go till. उससे ज़्यादा नहीं जाएगा. So now that's the problem. Now the problem states that we have to arrange people in groups of 4 groups, 4 people groups. Now how can these 4 people sit? Either they can sit over here, or else they can sit over here, or else they can sit over here. These 3 are the only possibilities according to the question. Only these 3 possibilities are present in the question. Now the normal case is quite hard in the sense of to implement it, the normal use case. Like it will be a bit more challenging with a more number of if-else conditions. So if we come to think of it, we have a fixed size. So first intuition we get that we have a fixed size, and what we need to find out if there is something reserved here, if there is something reserved here, if there is something reserved here. If there are anything reserved in those spaces, then we can be sure that in that range there can be no 4 group people staying. So in this case, in this row, as we can see, the maximum number of groups in one row can be how much? It can be 2. So the maximum groups taking the in whole theater would be how much? Would be equal to the number of rows into 2. This is taking into case I am very optimistic that each row has 2 groups possibility. This is the maximum optimistic. Now to get to the answer, what I would need to do is, we have a property of AND, bitwise AND, that if 1 and 1 will only give me 1. So if only these two are 1, only then we'll get the 1. That is the property of AND, right? So now I just need to find out whether in this 2 to 5, or else 4 to 7, or else 6 to 9, in these things individually, if there is something reserved or not. If there is reserved, then I cannot make a placement over there. I know that. So I'll just calculate for each row if there is something reserved between this, this and this, right? So how can I do that in O of one time once I have pre-computed something? So what I can do is, as there are only 10 elements, I can just represent these 10 elements as from 1 to 10 as an integer itself, right? As an integer or character itself, right? Which has like so on till 10. Now this can have 0 or 1 values only. This is a binary. If it is 1, we know that if it is 1 means it is already reserved, and I need to find out only between these, this and this, whether if there is a 1 or not. Now what I can do is, effectively this first and the 10th also I don't need, I don't care about those. So I can just remove and shift everything by 2 places and say whether if those, this much amount of the what we'll call the bits, right? So we can just effectively remove it. Now we can just take a look at the code. So over here, as we can see, first this is the optimistic case where maximum possibilities we are taking, maximum possibilities is n into 2, Now we need to decrease from this based on if there is some reserved in our sets, if there is some reserved seats in these three cases. So now this is a map which will maintain that according to every row will have a bitmask for it. How do we create the bitmask? Now for each of the rows we will be iterating through it. So this rs, we know that rs is a vector with only 2, 2, something like this. It is a pair rs. Now rs has 1 as well as rs has 0. Now what we need to do is that if we know that rs of 1, which is like we are already in some row, we know that, right? The row number will get by rs of 0. This is the row number. Now for each row we'll be carrying out that if any bit is reserved, I mean if any seat is reserved, we'll represent it by a bit. That bit, to represent it by some bit, we'll be doing this operation. What is that operation? We'll be taking 1, which is like this, and we will be left shifting it by rs of 1 minus 2. Why are we doing this? So suppose if it was 10, at 10 if it was there, if it 9 it was there, if this was reserved, so to represent this number, suppose 1, 2, 3 and 3 was reserved, right? Now to represent this in terms of the binary by shifting it, what I'll do, when I'll go to 3, what I'll do is I'll shift this by rs of 1 minus 2, which is like 3 minus 2, which is like 1. Now I'll just shift it by 1. So my number will become 0, 0, 0, 1, 0. Now when it comes to 9, at 9 I'll shift it by 7. So 1, 2, 3, 4, 5, 6, 7. I'll shift it by 7. Now I'll have this number in contention, right? Now this number, how many does it have? It has 8 length, and 8 is what we require, right? We don't require this 1 and 10. We don't require this only. So now this takes care of the logic wherein this is from back. If we see the seats, right, this is depicting the seat from number 2 to number 9 in this fashion for the row. From this fashion it is starting. And then this part I found it in the Leetcode editorial only, not in the editorial, sorry, in one of the solutions some guy had written this. So further looking into it, 0b signifies, it tells the compiler that hey compiler, this number and the operator, this number is a binary number and you need to perform bitwise operations. So it is just a compiler optimization technique. This is what I read, or else we could have just done and with this much part without telling 0b. So yeah, 0b does that for us. Now we'll have v as something like this. Now if we are doing it with 1 1 1 1 0 0 0 0, and then we will get that this part ending will be 1, which will be greater than 0, and hence this boolean will be true. Now what does this signify? Row is starting from here. It signifies that the third case is correct, not the first case. This signifies what? That the third case is correct. Now when we have 1 over here, right? Now when we are doing AND with this part, so it is only covering 1 1 1 1 and 0 0, but the other one was over here, right? So this will be 0 only, so this will be false, but this one again will become true. Now what does this say? This becoming true says that there was something in contention and this cannot be formed. So false says this can be formed because there was nothing in between, right? So that is the one thing that can be formed. because there was nobody reserving these 4 seats. Out of these 4 seats, all the 4 seats were vacant. That is why we got a 0. If there was anybody who was vacant in this, anywhere in this span, it would not have been 0, which means we can make 1. This true signifies again we can't make. So this is the case 1, case 2 and 3, if we are considering these as 1, 2 and 3. This is in that order. Now after doing this, what is this part? This part we are doing to find out if all the values are true, right? If all are true. If all are true means we have a contender over here also who is reserving something in this span, who is reserving something in this span, and who is also reserving something in this span. So nothing, no seat group can be formed in such a case. No seat group. So in our answer we had considered that optimistically that for every row 2 seed groups were considered by default. Now we just want to remove here no seed can be formed, which means we'll have to remove 2. So I am minusing 2. Now if all are not true and something is false out of this, if something is false, which means that can be formed, that group can be formed. Now if something is false, if these 2 are false, suppose if this one over here we have only 1 false. Now if 1 is false, then we can say that. So you might ask me, like, how are we calculating when this is also present and this is also present? In the sense, we can make a group over here also, and nothing is reserved in this or this. So that is already considered. That case is already considered over here. That we are considering. By default we are considering that both the pairs can be made. Now if both the pairs can be made, then it won't come in this map only. We are already negating it. When is the possibility that both the pairs come? When it is RS is equal to 1, or else RS of 1 is equal to 10. Now in this case we are not pushing it in the map itself. Now if we are not pushing it in the map itself, we won't get that row here. So 0 0 0 0 0 0 0 0 0 B. So this is not a possibility. Anything that goes into the map has to have at least 1 bit which is not which is set, 1 bit set at least. Now this takes care of the other logic, that if some bit is set, then either I need to remove both or else I need to remove 1. If any one can be formed out of these, then we'll be removing 1. If nothing can be formed, then we'll be removing 2. When can nothing be formed? If all these ranges have some seat reserved in between, right? So that was the solution. Yeah.